Good afternoon students, welcome back to chemistry class. Today we are going to study about grouping of elements based on electronic configurations. Grouping of elements based on electronic configuration. As we know about modern periodic table, the elements are arranged with periods and groups based on their atomic number. Okay, there are 7 periods and 18 groups are having the modern periodic table. The horizontal rows are called periods and vertical columns are called groups. Here, these 7 periods and 18 groups are organized based on the modern periodic law. Based on the modern periodic law. What do you mean by modern periodic law? The physical and the chemical properties of the elements or the periodic functions of their atomic number. What do you mean by modern periodic law? The physical and the chemical properties of elements or the periodic functions of their atomic number. Understood? Physical and chemical properties of the elements or the periodic functions of their atomic number. According to Mendeleev periodic table, the elements are arranged based on the increasing order of their atomic weight. But here, the modern periodic table, the elements are arranged based on their atomic number. Okay, so physical and chemical properties of the elements or the periodic functions of their atomic number. What do you mean by periodic function mean? That properties, the physical and chemical properties, it form repeated at regular interval. That is called the periodic functions. Okay, so the physical and chemical properties of the elements or periodic functions of their atomic number. Here, the placement of elements in the periodic table is closely related to its outer shell electronic configuration. The placement of elements in the periodic table is closely related to its outer shell electronic configuration. You know about the electronic configuration. What do you mean by electronic configuration? The distribution of electrons into various orbitals of an atom. Okay, the distribution of electrons into various orbital. About orbital, you know, the 3-dimensional space in which the probability of finding electron is maximum. That is called the orbital. Okay, so electronic configuration means distribution of electrons into various orbitals. S orbital, P orbital, D orbital, F orbital. These are the various orbital. Okay, distribution of electrons into various orbital of an atom. Here, the electronic and the periodic table is closely related to the electronic configuration, outer electronic configuration. Let us analyze the change in the electronic configuration of elements along the periods and down the group. Okay, how the electronic configuration change. The electronic configuration of elements along the periods and down the groups. How the electronic configuration will be changed. Okay. First upon, variation of electronic configuration along the periods. First upon, we are going to study about the variation of electronic configuration along the periods. Okay. We have already learnt that each period starts with the element having general electronic configuration NS1 and ends with NS2 and NP6. Okay, the previous section I explained that each period starts with the elements having the general electronic configuration. Listen here. Here, this is the periods. Totally, how many periods are there? 7 periods. Each periods, the elements from each period, it starts from S orbital, NS1. Okay, NS1. N is equal to number of period. For example, the first period, It starts from 1s1. Second period starts from 2s1. Third period starts from 3s1. Fourth period starts from 4s1. Fifth period starts from 5s1. Sixth period starts from 6s1. Seventh period starts from 7s1. Okay, so each period starts with the general electronic configuration, that is ns1, and it ends with ns2 np6. Okay, they start from ns1, all the elements, the electronic configuration starts from ns1 and ends with ns2 and np6. You see here, this is the outer electronic configuration for the last elements in the periods. Okay, hydrogen, and this is the first period. What is the first period? Hydrogen and helium is the first period. Hydrogen starts from 1s1 and ends with 1s2. Okay, second period, lithium to neon, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, here lithium starts from 2s1 and beryllium 2s2, boron 2s2 2p1, carbon 2s2 2p2, nitrogen 2s2 2p3, oxygen 2s2 2p4, fluorine 2s2 2p5. After that, neon 2s2 2p6. Okay, start from 2s1, ends with 2p6. Similarly, the sodium, third group start from sodium. Okay, atomic number neon after sodium 11, neon atomic number 10. So after sodium atomic number 11, it starts from 11. What is the electronic configuration? 3s1. Third period starts from 3s1 and it ends with 3s2 3p6. Okay, sodium starts from sodium, after that magnesium and aluminium, silicon, phosphorus, sulfur, chlorine. After that it ends with argon. Okay, these are about the electronic configuration. Understood. So third period starts with filling of valence electron in the 3s orbital followed by the 3p orbital. Okay, 3s to 3p6. The fourth period starts with filling of valence electron from 4s orbital followed by 3d and 4p orbitals accordance with Offer principle. Okay, the fourth period, the filling of valence electron from 4s. Fourth period means 4. Number of period means 4. Okay, the fourth will listen here. 4s1, potassium. It starts from potassium outer electronic configuration 4s1, and this 4s orbital followed by 3d and 4p. Okay, the fourth period, the filling of 3d orbital starts with scandium and ends with zinc. Okay, 3d orbital starts from fourth period. First two elements, it is the 4s orbital, 4s1, 4s2, according to Offer principle. After the 4s orbital, after that 3d orbital will come. Okay, so 3d orbital here, scandium. The scandium starts with 3d orbital and it ends with zinc. Okay, 3d 10 elements, middle having the 10 elements. It is the 3d orbital. Okay, these 10 elements are called the first transition series. Okay, you know this periodic table, we can separate it as 4 blocks. Okay, what are the blocks? S block, P block, D block and F block. Okay, S block element, first two groups elements are called S block element. Second, the group 13 to group 18 group elements are called P block elements. Okay, because the outer shell electronic configuration ends with P orbital. The middle elements, it starts from 3d orbital, 3d. Okay, 3d 1 to 3d 10. 3d orbital, the electronic configuration, it enter the d orbital, 3d orbital. It starts from 3d 1 to 3d 10 here. Okay, so the middle elements are called transition elements. Okay, and also it is called as D block element. And the down the periodic table, two periods are having. These periods are called the inner transition elements or F block element, because these outer shell electrons, it is enter in the F orbital. Okay, so it is called as F block element, or otherwise called, it is placed in between the transition elements, so it is otherwise called as inner transition elements. Okay, so here the fourth period starts from 4s1 orbital and followed by 3d and 4p orbitals according to alpha principle. Okay, in the fourth period, the filling of 3d orbital starts with scantium and ends with zinc. These 10 elements are called first transition series. Okay, first transition series. How many transition series are there? There are 4 transition series are there. So the scantium to zinc we call as the first transition series. Similarly, the 4d, 5d and 6d orbitals are filled in successive periods, and the corresponding series of elements are called second, third and fourth transition series respectively. Okay, here how much transition series are having? This is the scantium to zinc first transition series, and yttrium to cadmium second transition series, lanthanum to mercury, it is the fourth transition series. After that, actinium to copernicium, this is the fourth transition series. Okay, wow. So first transition series starts from 3d1, second transition series starts from 4d1, third transition series starts from 5d1, and fourth transition series starts from 6d1. Okay, understood? And in the sixth period, okay, in the fifth period starts from 5s1 orbital and followed by 4d, and it ends with 5p6. Okay, fifth period starts from 5s orbital, it followed by 4d and 5p. Here how much elements are having? Totally 18 elements are having. Okay, 2 S block elements and 10 transition elements and 6 P block elements. Totally 18 elements are having the fifth period. Okay, and after the sixth period, it starts from 6s1 orbital. Outer electrons are present in the sixth period. It starts from cesium outer shell, outer electrons, it enter in the 6s orbital. Okay, 6s orbital, and here this cesium, it is followed by 4f, 5d and 6p orbitals. Okay, it ends with 6p6. Okay, start from 6s1, it ends with 6p6. Okay, so the what about the middle orbitals? 4f, 5d and 6p. Totally how much elements are having the sixth period? Totally 32 elements are having the sixth period. Okay, after similarly the seventh period. Seventh period also, it starts from 7s1 orbital. Which one is the 7s1 elements? Francium. It starts from francium to organazone. Okay, francium, it starts from 7s1 and it followed by 5f, 6d, 7p, totally 32 electrons, and it ends with organazone. Okay, francium 7s1 to organazone 7s2, 7p6. Okay, understood? So the sixth period, in the sixth period, that inner transition elements are occupied in the sixth period. Okay, so sixth period and seventh period having the inner transition elements. So the first sixth period elements we called as the first inner transition series, or otherwise called as lanthanides. Similarly, in the seventh period, 5f orbitals are filled and its 14 elements. It constitutes the second inner transition series called as actinides. First inner transition elements are called as the lanthanides. Second inner transition elements are called as the actinides. Okay, understood? These two series are placed separately at the bottom of the modern periodic table. These two elements, two series. What are the two series? The lanthanides and the octinides. Lanthanides and the octinides. It is placed at the bottom of the modern periodic table. Understood? These are about the variation of electronic configuration along the periods. I hope all of you understood about that. Let me repeat. The first period, it is 1s1. That is n is equal to 1. So first period, it starts from 1s1. Okay, 1s1 and 1s2. The second period, n is equal to 2. So it starts from 2s and completed with 2p6. All the elements in the second period or starts from 2s1 to 2p6. Okay, and third period, n is equal to 3. So the elements, the electronic configuration, it can start from 3s1 to 3p6. Okay, the first elements of the third period element, the electronic configuration, it can start from 3s1 to 3p and completed with 3p6. Okay, and fourth period, when n is equal to 4. Okay, so the fourth period starts from 4s1 and it followed by 3d and it completed with 4p6. Okay, and fifth period, n is equal to 5. Fifth period means when n is equal to 5, it is called fifth period. So it can start from 5s1. The elements electronic configuration, outer electronic configuration starts from 5s1 to it is followed by 4d and it ends with 5p6. And sixth period, n is equal to 6. Here it starts from 6s1 and followed 4f and 5d and it completed with 6p6. Okay, and finally seventh period, the first element starts from 7s1 and followed by 5f and 6d and completed with 7p6. Okay, these are the electronic configuration for the elements and according to periods. Okay, then we are going to study about variation of electronic configuration in the groups. Variation of electronic configuration in the groups. As we know, the electronic arrangements of atoms help to explain the properties of the elements and structure of the periodic table. Okay, you know there are 7 periods and 18 groups in the Mendeleev period, in the modern periodic table. Okay, now we are going to studied about the periods. Okay, we learned clearly about that. 7 periods we clearly learned. Now we are going to study about the 18 groups. Okay, the elements of a group have the similar electronic configuration in their outer shell. Listen here. The elements of a group, elements of a same group have similar electronic configuration in their outer shell. Okay. How many groups are having here? Totally, the periodic table, modern periodic table, it is divided into four blocks. Okay. What are the four blocks? S block, P block, D block and F block elements. Okay. S block elements, P block elements, D block elements and F block elements. Okay, listen here. This first and second period we called as the S block element, and group 13 to 18, the elements are called as P block elements, and group 3 to 12 in the middle of the group 3 to after the S block element having the D block element. Okay, 3 to 12, that is called D block element. And F block element means F block element takes place at the bottom of the periodic table, but it is not the this is the correct position of this F block element. This the F block element, what is the position of F block element? It is the middle for the sixth period and seventh period. Okay, sixth period and seventh periods, the F block elements are situated. Okay, after lanthanum, the lanthanides are takes place after lanthanum, and actinides are takes place after actinoids. Okay, wow. These why we are called as the F block element, because the outermost electrons are enter into the F block elements. The new electrons enter into the F orbital, so it is called as the F block elements. Okay, so the elements in the same group have the similar properties because they have the same number of electrons in their outer shell. Okay, elements in the same periods elements have the similar chemical properties because they have the same number of electrons in their outer shell. Okay, for example, the S block element, we see the S block element. First and second group elements are called as the S block element. The first group, the same group, first group, how much elements are present? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These all elements have the same number of outer shell electrons. Okay, the hydrogen, how much electrons are present in the outer shell? 1s1, only one electron. And lithium also only one electron, 2s1. Sodium only one electron. Potassium only one electron. Rubidium only one electron. Cesium only one electron. Francium only one electron. Understood? So the elements in the same group having the similar chemical properties because they have the same number of electrons in their outer shell. Okay, the S block and the P blocks elements have the all the groups having the same outer shell electrons, so have the same chemical properties. But the D block element, they're called as the transition elements. D block element, otherwise we call as the transition element, but here the some elements have the different properties. Okay, I will explain later about that. So the group 1 and group 2 are called as the S block element. The group 1 element again classified as the alkali metal, and group 2 elements again we classified as the alkaline earth metal. Okay, S block element again classified as alkali metal and alkaline earth metal. Okay, these two elements, these are the soft metals and low melting and boiling points and low ionization energy. Highly reactive. These S block elements, alkali metal and alkaline earth metals, are highly reactive than other elements. Okay, it is easily react with other element, hydrogen. You know, hydrogen is the very high reactive element. Okay, so the S block elements are very high reactive and low melting and boiling points. Okay, these are the characters of the S block element. The S block element, all the elements having the alkali metals having the same chemical properties. Okay, alkaline earth metal having the same physical and chemical properties. Understood? These are about the S block element. And the general electronic configuration for the S block element, the general electronic configuration S block group 1 and group 2 elements are called S block element. These elements having the same general electronic configuration, that is NS1. Group 1 elements electronic configuration NS1 and group 2 elements electronic configuration NS2. N means, what do you mean by N? N means number of shell. Okay, N means number of shell. Okay, for example, for the 1s orbital, first group elements, what are the first group elements? Lithium, sodium, potassium, rubidium, cesium, francium. Okay, lithium atomic number 3. How many cells are having? Totally first 2 into 1. Only 2 shells are having. Okay, and the sodium atomic number 11. 1s2, 2h2, 2p6, 3s1. Okay, so outer electronic configuration 3s1. Okay, so the N means number of shells. Okay, so the general electronic configuration for group 1 elements, that means alkali metals are NS1 and alkaline earth metals are NS2. General outer electronic configuration. All the elements having the NS1 configuration. Potassium atomic number 19. So for 18 we can take as the stable inert gas. Nearby stable noble gases are gone, that is 18, you know. After that 4s1. Rubidium, what is the atomic number? Rubidium 37. We can take as the krypton, it is the nearest noble gas, and 5s1. Okay, and cesium atomic number 55. So here, which one is the nearest noble gas? Xenon. Okay, xenon and 6s1. Francium atomic number 87. 87 means which one is the nearest noble gas? Radon. Radon is the nearest noble gas. So radon atomic number 86, you know. So remaining 7s1. Okay, so this is the S block element. This S block element, there are 2 blocks are having alkali metals and alkaline earth metal. This is the alkali metal group 1 elements. All the group 1 elements having the similar outer shell electronic configuration. So these all elements having the similar chemical properties. Understood? Like that the group 2 elements also. Understood? The beryllium, magnesium, calcium, strontium, barium and radium. Okay, and secondly, the group 13 to group 14 elements are called as the P block elements. Group 13 to group 14 elements are called as the P block elements, or otherwise called as the representative elements. P block elements are otherwise called as the representative elements. Group 13 to group 18 elements are called as the P block elements or representative elements, and have the general electronic configuration here NS2 and NP 1 to 6. Okay, by NS2 and NP 1 to 6. P block element, group 13 to 18. Totally how many groups are having here? Totally 6 groups are having. Okay, so general electronic configuration NS2 and NP1 to 6. Okay, wow. All the elements in these p block elements are having the general electronic configuration. So all the elements are similar chemical properties. Okay, group 13 elements, for example, group 13 elements: boron, aluminium, gallium, indium, thallium, and nihonium. Okay, all the elements are having the similar electronic outer shell electronic configuration, that is NH2 and NP1. NP1. Okay, boron 2H2 2P1, aluminium 3H2 3P1, gallium 4H2 4P1. Okay, but these are the similar outer electronic configurations, so similar chemical properties. Understood? And these elements, the group 16 and group 17 elements are called, the group 16 elements called as the chalcogen family or oxygen family, and the group 17 elements we called as the halogens: fluorine, chlorine, bromine, iodine. Okay, these are the halogens. And the elements of the 18 group, already we studied about that is we called as the inert gases, because all the elements in the group 18 elements have the similar stable electronic configuration, that is NH2 NP6, stable electronic configuration NH2 and NP6. These elements we called as the inert gases or noble gases. Understood? And what about the D block elements? The elements of the group 12 are called as the D block element, group 3 to 12. Okay, the elements of the group 3 to 12 are called as the D block element. Another one name, it is called as the transition elements. Okay, group 3 to group 12 elements we called as the transition elements. Okay, transition elements. Here transition elements, there are two types of elements are having. One is transition elements, and the inner transition elements are having the transition series. Okay, transition elements, the outer electronic configuration for the transition elements, that is NS1 to 2 and N-1 D1 to 10. N-1 D1 to 10. What do you mean by N? Means number of shells, N-1 means penultimate cell. Okay, for example, here this is the nucleus, this is the shells. Okay, you know, this is the shells, this is the final outermost shell, and this is the N-1 shell, that is penultimate shell. Okay, before the outermost shell we called as the penultimate cell. Okay, so it is mentioned here N-1. Okay, so general electronic configuration for the transition elements or D block elements are NS1 to 2 and N-1 D1 to 10. Okay, the electronic configuration for these elements are the s orbital 1 to 2 and d orbital 1 to 10 elements are having. Understood? And then the lanthanides and actinides, which takes place in the bottom of the periodic table. See, this is the periodic table here. The bottom of the periodic table having the lanthanides and the actinides. Okay, such elements are called as the inner transition elements. Okay, because it forms in between the transition elements, so it is called as the inner transition elements. Okay, what are the inner transition elements? That is lanthanides and actinides. Okay, the lanthanides forms in between the lanthanum and hafnium. The lanthanum form lanthanides group. Lanthanides element, there are 14 elements are having the lanthanides. These lanthanides is placed in between the lanthanum and hafnium. Okay, and actinides, these actinides it placed in between the actinum and rutherfordium. Actinum and rutherfordium. Understood? The elements with the atomic numbers are 58, 57, that is lanthanum, 58 to 71, which follows the lanthanum. Okay, and the elements with the 90 to 103, which follows the actinum, are called the actinides. Understood? The inner transition elements are sometimes are called as the F block elements. F block elements, since in this region of the orbitals are being filled in. Okay, in this the F block, the electrons are start to fill in the F orbital. So these elements are called as the F block elements. Okay, the general electronic configuration for the lanthanides are 4f1 to 14 and 5d0 to 1 and 6s2. Okay, this is the electronic configuration for the lanthanides. 4f1 to 14, 5d0 to 1 and 6s2. And actinides, so it's the general electronic configuration for the actinides, that is 5f0 to 14, 6d0 to 2 and 7s2. Okay, this is the general electronic outer electronic configuration for the actinides. Important, very very important. General outermost electronic configuration, outer electronic configuration for the lanthanides are 4f1 to 14, 5d0 to 1 and 6s2. Okay, the general outer electronic configuration for the actinides 5f0 to 14, 6d0 to 2 and 7s2. Very very important. These elements, the lanthanides and actinides, are metallic in nature. All the D block elements are the metallic in nature, and metal, you know, that is high melting and boiling points, and their compounds are mostly colored. Okay, they react with another compounds to form the complex. Okay, complex, these complex compound are mostly colored compounds we get. Okay, these are about the groups. Okay, assignment, today assignment. Okay, you write the electronic configuration for the S block element general electronic configuration at ns1 to 2, and general electronic configuration for the P block element, this is S block element, and P block elements general electronic configuration ns2 np1 to 6. Okay, and general electronic configuration for the D block elements ns1 to 2 and n-1 d1 to 10. Okay, and general electronic configuration for the lanthanides 4f1 to 14, 5d0 to 1 and 6s2. Okay, and general electronic configuration for the actinides, that is 5f0 to 14, 6d0 to 2 and 7s2. Okay, this is your assignment, today's assignment. What is the today's assignment? Write the electronic configuration for the S block, P block, D block and lanthanides and actinides. Write the electronic configuration for S, P, D and lanthanides and actinides. Very very important. Very very important. Study well. Okay, this is very very useful for your further your chapters. Very very important. And also another one assignment. Study the what are the elements or occupy in S block. Elements name. Write the elements name for S block. Okay, study and write. Very very important. Okay, if you are having book, take your book now. Students, take page number 74 now. Periodic table, modern periodic table take now. Just let me repeat. Okay, this is the modern periodic table here. How many blocks are having? There are 4 blocks: F block, D block, and P block and F block. Okay, the S block elements. These are the F block, S block elements. The alkali metal and alkaline earth metal. You should study these 2 group elements. Group number 1 and group number 2. Alkali and alkaline earth metal. Hydrogen. It is the place for here. Here the place for the hydrogen, because 1s1. This is the first 1s1 orbital. Electron at occupy the 1s orbital, 1s1 orbital. So this is the place, but the hydrogen form an isotope. Okay, the properties of the hydrogen, it is maybe differ from the other elements of the s orbital. So the hydrogen place, it will be occupied here. Okay, understood? So these are the group 1 element: hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Okay, and atomic number also you should study. Lithium 3, sodium 11, potassium 19, rubidium 37, cesium 55, francium 87. Also the second group elements: beryllium, magnesium, calcium, strontium, barium and radium. You should study these 2 group elements. You should study. Okay, these are about the P block elements, otherwise called as the representative elements. 13 to group 13 to group 18 elements. Okay, group 13 element we called as the boron family, because the here what are the elements are present here? Boron, aluminium, gallium, indium, thallium and nihonium. Okay, understood? See here all the elements having the same outer shell electronic configuration. Boron outer shell electronic configuration 2s2 2p1, aluminium 3s2 3p1. Okay, and gallium 4s2 4p1, indium 5s2 5p1, thallium 6s2 6p1, nihonium 7s2 7p1. Okay, this is the characteristic of the groups. Okay, this is the inert gases, noble gases group. You know, this is the stable electronic configuration having these group 18 elements, otherwise called as the 0 group element, noble gases, because it unreact with another elements. Okay, it does not react with any other elements. So it is the stable electronic configuration: helium, neon, argon, krypton, xenon, radon and oganesson. Okay, helium atomic number 2 electronic configuration 1s2, neon 10 2s2 2p6, argon 18 3s2 3p6, krypton 36 4s2 4p6, xenon 54 5s2 5p6, radon 86 6s2 6p6 and oganesson 7s2 7p6. This is the last elements in the periodic table. The atomic number for the element 118. Okay, 118, which occupies the 7th period, last period and last group. Understood? These are about the noble gases. Okay, this is the boron family, carbon family, nitrogen family, because nitrogen is the first element, so it is called as the nitrogen family. Okay, group 16 elements are called as the oxygen family, otherwise called as the chalcogen family. Chalcogen. Okay, oxygen family, group 16 element we called as the oxygen family, because oxygen is the first element, but otherwise we called as the chalcogen family. Okay, group 17 elements. Here all the elements are the halogens. Okay, halogens. What are the halogens are present here? Fluorine, chlorine, bromine and iodine, and the similar electronic configuration astatine and tennessine. Okay, these are the group 17 elements. Understood? These are about the P block elements. And D block elements, group 3 to group 12. Group 3 to group 12 elements are called as the transition elements, and this is the inner transition elements. Why we called as the inner transition elements? Because it occupy the position in between the transition elements, so it is called as the inner transition elements. Otherwise we called as the F block element, because the outer electrons are enter into the F blocks. Okay, F blocks. Listen here: cerium 4f2 5d0 6s1 6s2 and 4f3 4f4 4f5 4f6. Okay, these are the electronic configuration. Okay, for the F block elements. These F block elements may be enter into the it takes place. This is not the actual place for this lanthanides and actinides. The place for the lanthanides, it in between the lanthanides, lanthanum and osmium. Okay, in between the lanthanum and osmium. Okay, understood. The actinides, the place for the actinides, it in between the actinum and the rutherfordium. Okay, understood. Check the atomic number also. Lanthanum 57 and after that cerium 58 to 71. Cerium to lutetium. Okay, here after 71, 72 it is the hafnium. Okay, like that. The actinium 89, atomic number 89. After that thorium. Okay, thorium 19, 92, 103, the thorium to lawrencium. It takes place in between the actinum and the rutherfordium. Okay, so these elements we called as the actinoids. Okay, you should study the outer electronic configuration 4 of N2, 4 of N, or 4 of 1 to 14 and 5D 0 to 1, 6 is 2. Okay, very very important, study well. And a D block element, when we are seeing the D block element, sometimes some elements behave the different chemical properties between these same groups. Okay, because the electronic configuration also differ for the D block element. Okay, D block element otherwise called as the transient elements. Transient, what do you mean by transient? Means change. Okay, some elements in the D block maybe change their chemical properties also. Okay, understood about this. The D block element group 3 to group 12 elements we called as the D block elements. Okay, and F block elements, cerium to lutetium, that is lanthanides and actinides, otherwise we called as the F block element. It otherwise called as inner transition elements. Understood? Okay. Thank you all of you.